Section 10, rail grinding. Rail grinding is vital maintenance of vital maintenance practice that will be applied consistently can ensure the prolonged rail life. The rail grinding is nearly achieved to the most optimum wheel rail contact patch prevent excessive wear. The utmost importance of the railway to control the normal process of the wearing fatigue of the railhead extended with the life of the rail, achievable with a proper track and maintenance sustainable rail management program. One of the key factors of the rail management program is sufficient rail grinding program. A rail accumulates tonnage of rail contact patch will verify the contact promote undesirable plastic flow or the rolling contact fatigue, head checking, spalling, shelling, and flaking. Geometrically alteration of the railhead affects the load stress that initiate with the rail defect of the rail failure. Benefits of rail grinding. The rail grinding is a well-established process of the reduction and control in the rail contact fatigue development. The primary benefits of rail grinding can be categorized by these four following areas. 1. Remove the existing rolling contact fatigue of the preventing development into severe condition that can result in additional damage to weakening the rail section. 2. Reprofile the railhead desired transverse shape, improve the performance of wheel rail contact patch. 3. Contact surface defects of such engine drive burns and dip belt welds. 4. Improve rail inspection system capabilities. The key to obtaining the benefits of the rail grinding to have regular grinding plan, usually properly type of equipment grinding strategy. Figure 59 shows the freshly ground rail. Common rail grinding strategies. Preventing grinding. The preventing grinding is considered to be by the many railroads to be the most beneficial strategy used in controlling rolling contact fatigue, developing in a rail management plan. Preventive grinding is a method of resulting in removal of minimal rail steel with the frequently grinding cycles. The objective of the preventing the grinding strategy is to grind higher to obtain the properly profiled rail surface. To prevent the grinding strategy can be initiated installing a new rail and can be achieved through the use of other grinding strategies to shape the rail to its desired profile. They initiated the preventive storage if in this strategy and sharp curves of ground more frequently, slight curves and tangent is ground less frequently. Preventive gradual grinding. The preventive gradual grinding process is performed as a slow rate speed, increase the grinding motor power, optimizing grinding patterns, decreasing the grinding interval, increasing the amount of rail seal removal. The strategy is often used on rail that is not previously used by previous preventing grinding strategy to improve rail condition. The preventing grinding strategy is initiated. Maintenance grinding. The maintenance grinding strategy uses much longer intervals between the grinding cycles, more than range steel removed, performing multiple slower grind passes, usually on curves, and can prevent heavy rolling stock fatigue developing damage. However, it can adversely shorten the rail life. Corrective grinding. Corrective grinding is mostly used when the rail has reached a severe advanced rate in rolling contact fatigue. The grinding frequencies are normally driven by actuated tonnage instead of normally driven by the other factors in significant shelling, development, corrugation, presence of other surfaces and anomalies. Corrective grinding will result in removing large quantities of rail steel, multiple low-speed phases. Optimum rail grinding strategy. The purpose of the grind to achieve is the longest life of the rail. To prevent the rail maintenance practice is designed to result in rail removal one part of the parent head and the loss of the reach maximum effective use them because of the fatigue. The best rail grinding strategy would normally consist of a targeted rail profile for the areas that promote low wear rates and low contact patch stress and proper vehicle stability. 2. The surface quality results meet the standard roughness and facet width of the suitable for the area. 3. The cycle adequately maintain balance of the wear of the fatigue. And 4. Loss of cost per mile. Usually a strategy that meets the exceeded result will achieve the rail life. Preventive rail grinding strategy along with the proper development rail lubrication, friction management are essential in an excessive rail management program. Figure 60 shows a rail grinder at work. Work-hardened region. A work-hardened region in a rail will develop under the load of the passage tonnage over the rail, and the range is important to protection to reduce the rail wear, preventing the development of the rolling contact fatigue of the modern rail, and improve the hardness of the region normally developed in the depth of a quarter of an inch below the railhead surface. An older rail with a low hardness of the region could develop in depth of as much as a half an inch below the railhead surface to prevent the grinding, the movement, the minimum optimum rail seal during the grinding process, wherever the corrective grinding removes the more a substantial amount of the rail steel. When consisting of the grinding strategy, it is important to prevent the removal of the beneficial working harding area and protect the rail steel from wear. Rail profiles. Rail profiles maintenance is necessary. USA Railway is to help prevent long life of the rail, reduce unnecessary capital investment. Rail grinding is achieved by the optimal rail wheel contact conditions. Rail grinding is optimal rail profile managed by the talents of preventing the grinding, assisting with removing the excessive rail contact stress and rail wear. Optimal railway profiles. Rail must endure the varying array of wheel profiles while in service. The various shapes of the wheel can range from new to wide flange, thin flange, or hollow, or severely worn. Software is available and designed to optimal rail profile tangent curve track and minimize the effect of the rail contact stress various shapes have on the rail. An optimal rail profile can improve the rail stability, steering ability of the curve. Tangent curve. This says grinding radius of 10 inches radius. The tangent truck are grounded to reduce the central route running band and running band flooring either gauge or field side of the railhead. These rail profiles are designed to reduce the following effects of the rail wheels. Tangent track profiles are also designed to increase the rail life curves. Tangent tracks lower grinding power required, lower the lateral serve forces where rail interface, improve wheel life, and lessen the amount of fuel consumed. High rail profiles. Rail profiles have improved the high speed of the curve, high size of the curve, the more efficiently distributed with the contact of the stress of the middle, intermediate, sharp curves. The essential of the high rail curve avoided with the localized stress fatigue developed while ensuring the vertical curving performance is optimal. The profiles are designed to minimize rail wear, development of rail contact fatigue, and reduce fuel costs. Low rail profiles. Optimal low rail profiles are designed to eliminate the concentration of stress fatigue caused by hollow wheels and wide gauge heavy haul railroads. The design are beneficial to improve the curve steering of the maximized vehicle curving performance. Many of the low rail profiles are designed to reduce metal removal from per grinding cycle, which will while still controlling loading and contact stress. Grinding equipment. Rail grinding machines come in various sizes and conditions depending on the productive requirement. The machines have grinding stones on the rotating the perpendicular to remove the metal from the surface of the metal. Longitudinal facets and ridges. The wells, the width of the facets determine the rail profile, surface finishes, appearance based on the amount of the metal removed. The larger number of the facets with the fewer transition loads and then become the facets and improve the rail profile, increase the amount of metal that will be removed from the rail head. The amount of the facets increased by the making of the numerous grind passes by the small sized grinders, increased by the number of stones used in grinding. In order to reduce the track occupancy, the time is normally used in the grinding stones and have the ability to remove metal and shape of the railheads with one pass. Smaller sized grinding machines normally use 28 to 24 grinding stones, while enlarging the production of the grinding machines may have only 48 to 96 grinding stones. The large production type of the grinding are capable of achieving the target rail profile with one grinding pass. The designing of the grinding stone is determined with the metal removed to the surface finish expectations. Both expectations can influence the use of life of the stone. The stones are made of the abrasive grit metal material with the type of resin bond. The grit size bond are important components of the stone performance. Larger grit size will remove the metal material from the rail surface, leaving a rougher finish. The grade type of the grit used in the stone have distinctive fracture characteristics. The degrees of graduation, the type of the quality residing in the influence of the ability to resin the bond of the grit. This also influentially metal removal capabilities of the stone. The region of metal stone independently amount of the force applied between the stone and the railhead. The power required of the stone consistent speed as force is increased if the key factor minimum forces with power are required to ensure the stone penetrate the steel and remove the metal. The projections is increased with the great pressure and power applied with the stones. The region of metal removed affected with the machine is increased with the will result in the amount of metal removed from the decrease. However, the higher power level of the stone pressure can result in high pressure speed grinding capability. The railhead surface finish is determined by the depth of the fastest ridges resulting from the grit scratches. However, the slow and coarse stone grits will result in fewer facets and rougher surface finishes. Section 11 is definitions.